The Sky This Month with your host, Dave McDonald.
Welcome to The Sky This Month. I'm your host, Dave McDonald, and this is February 2024. May I remind you, it's a leap year. We get an extra day in February this year. So happy birthday in advance to all of those of you who have a birthday on February 29th, because you grow older at a much slower rate than the rest of us, which is kind of cool. So we got a great show for you. We are going to be talking to Dr. Fran Bagenal, who is a research physicist at the University of Colorado, and she's currently working with the Juno mission, which is at Jupiter, and they just made some amazing discoveries at Io. We're going to be talking with her about that. And we're going to talk about some of the great things that you can see in the night sky. And one place that you can go to check out what's going on also is the McAuliffe Shepard Discovery Center, which is in Concord, New Hampshire, off of exit 15. And every first Friday of every month, and it's going to be March 1st will be the next one after you're watching this. March 1st will be a Superstellar Friday at 7 o'clock at the McAuliffe Shepard Discovery Center in Concord. Check it out at StarHop, StarHop.com. So behind me you can see the Andromeda Galaxy, and I'm going to show you where to find the Andromeda Galaxy in the night sky. It's going to be a great venture to find it, because you can actually see it with the unaided eye. Well, let's talk about some of the neat things that are up in the sky for the month of February. So let's look at this next picture. Check this out. We've got Mars, Mercury, and Venus. February 2nd, February 3rd, that's it. So I hope that you are watching this early enough in the month to be able to get out. This is in the morning before the sun comes up. Binoculars may be helpful, but you can see how close to the horizon Mercury and Mars are here, and Mercury in particular is getting ready to go below the horizon. So check it out, February 2nd, February 3rd, in the morning before the sun's up. Binoculars can be a big help. You can't miss blazing Venus, and then kind of down to the left side, you'll pick up Mercury and Mars. Mars is going to show up again, but this is kind of your last chance to see Mercury. So let's go on. And then next, we're going to look at something else that's disappearing from sight, and that's going to be the planet Saturn. Saturn has been great for months over the summer. We've enjoyed looking at Saturn. If you had a telescope, you enjoyed looking at Saturn's rings. It's really a treat. But you got about maybe the first 7 to 10 days of February, and it's going to be gone. And Saturn is so close, you can see here, to the horizon. And this is about 45 minutes after sunset. And again, it's visible, available to you, really close to the horizon. So sometimes binoculars can help even to find Saturn if it's in the glare of the sun. But around February 10th, it's going to be gone, because February 28th, Saturn is actually going to be in a position we call superior conjunction, where it's going to be behind the sun, and then over time it'll reemerge in the morning sky. So Saturn, your last views, you'll get your telescope out and enjoy looking at the rings. Now you can see, like right on top of my head is Jupiter. So as you're looking out at 45 minutes or so after the sun sets, and you look up, you'll see Jupiter. Jupiter you can't miss. It's the brightest object in the night sky unless the moon is up in the area. And so now I want to move us to February 5th, okay? And so we're going to kind of take a closer look at Jupiter. So let's look at this. And you can see here we have the planet Jupiter and a couple of the moons here. We've got Io and Europa. Actually, we don't see Io quite yet. So this, you can look up for the specific timing online, but this is February 5th. around 10 o'clock, so like 9:55 to 10:05, in that vicinity, you're going to get to see Europa disappear, and the planet Io, which later on I'm going to call it Io, and we're going to talk a lot about Io tonight with Dr. Bagenal. But you check it out, and here you can see Europa, and then just 5 minutes later, next slide, gone. And it's kind of neat to watch it through you need a telescope to see this happen, to be looking through a telescope and to realize these moons, they are in motion. They are orbiting Jupiter. And that's one of the things that got Galileo in trouble. So enjoy trying to find the moments in time when planets, I should say moons, appear from behind a planet, or they disappear to behind a planet, like Europa is going to do, and Io is going to appear. So this is around 10 o'clock, 5 minutes before, 5 minutes after, on February 5th. Right? Next. So now we have something very cool happening here. So if you look down here, you got Venus and you have Mars. And this is happening on February 22nd. And this is going to be in the morning sky, Venus and Mars so close together, we call that a conjunction. And you can enjoy that in the morning of February 22nd. And so what we're going to do now, we're going to go to the evening. We thought might hang around February 22nd, so we don't jump to too many dates. So let's look next at February 22nd, and we're going to be looking at the north sky. So know where north is, and I'm going to give you a little guided tour of how to find the North Star and some of the other constellations that are in the north. So we start typically with, this is around 6:30 or so, and the Big Dipper. So you can see the Big Dipper is on its handle, kind of looking like it's on its handle here. And if we take the two end stars of the Dipper part, Merak and Dubhe, and you make a fairly straight line, you end up at Polaris, the North Star. And notice the North Star is not super duper bright. It's about number 48 or 49 on the hit parade of stars. And another thing in terms of observation that maybe you've never noticed before, but take a look at the middle star of the handle of the Big Dipper. There's two stars there, and you can actually see, if you take time to observe, you can say, my goodness, there are two stars there. Dave was right. Of course he's right. Mizar and Alcor are the names of the two stars. Mizar, or Mizar, is the brighter one, and Alcor, not to be confused with Al Gore, is the fainter one. Now, another reason I point out that middle star to you is if you take that middle star and you go through the North Star, you end up with this shape here that kind of looks like an M or an E or a 3 or a W. And we're going to help us see that. So next slide, we're going to put some lines onto this. And you can see the Big Dipper. And you see these other lines connected to it because the Big Dipper is not a constellation. It's part of the constellation we know as Big Bear. So the tail is elongated. Check out your mythology for why. And then you have the head, the paws, the back legs here of the bear. And then the Little Dipper, notice that Polaris is at the end of the handle of the Little Dipper. And if we take that middle star, Mizar and Alcor, and go through the North Star, we end up with this W shape, or it kind of looks more like an M right now, and that's Cassiopeia, the Queen. Then we have this kind of looks like the side of a barn or an envelope. This is Cepheus, the king. So we have King Cepheus, Queen Cassiopeia. I wonder if they had a daughter. Let's look at the next slide, and we see, voila, yes, the king and queen had a daughter, Andromeda, right here, who unfortunately is chained to the sea's edge to be eaten by Cetus, the sea monster. Another story about that another time. It's an interesting story. And so we have the king and queen and the daughter, Andromeda. So you remember we started the show with the Andromeda galaxy behind us. I want to show you how to find the Andromeda galaxy as you look north. So let's go to the next slide. And if you take Cassiopeia, which I've moved over to here, you see it has an acute angle, which is less than 90 degrees, and it has an obtuse angle, which is greater than 90 degrees. And if you take that smaller angle, it points to this fuzzy spot. And you can see this fuzzy spot in the night sky. With averted vision is helpful. You just kind of look a little off to the side and you can see it better because it hits the rods in your eye rather than the cones, which do the color, but they're not as sensitive to light. And you'll see the Andromeda galaxy right here, which is part of the constellation, of course, Andromeda. So let's look next, and we see this is what you're looking at. Now, even if you have a telescope in your backyard, you're not going to, this is a Hubble Space Telescope view of the Andromeda galaxy, so you're not going to get to see it quite like this. But it's amazing to think that you're looking at something that's over 100,000 light years in diameter, over 100,000 light years across. It's crazy. And so I thought I'd point that out to you. It's a thrill to just look at it with the unaided eye and realize it's 2.5 million light years away. Crazy stuff. So next, I want to show you once again, because you don't have the lines and the pictures up in the sky. So you remember you're going to take that narrow angle and you're going to follow it until you follow it to this little fuzzy spot, the Andromeda galaxy, 2.5 million light years away. In order to introduce to you our speaker, Dr. Fran Bagenal, who is a research scientist in the Department of Physics and at the University of Colorado, and she's going to be talking about the mission at Jupiter, which is called Juno. And so we have the planet Jupiter here with the great red spot. And then the moon Io, which she pronounces Io. I'll ask her about that when we get there. And Io has the closest orbit of any of the 4 Galilean moons to Jupiter. And we're going to talk about that, and I think you're going to be thrilled at some of the latest and the greatest, hot off the presses information about Jupiter, the Juno mission, and the moon Io. So let me introduce to you Dr. Bagenal. I hope you enjoyed that chat about what you can see from your backyard, the planets and the stars and such. It's the greatest show on Earth, and you can see it from your backyard. I just want to take a quick moment and thank our viewers. If you're watching on your local cable TV station, it's awesome that we have so many stations that are airing our show across the country. Thank you. And we're up to 10,000 viewers on our YouTube channel. So thank you, viewers. Tell your friends about us, you know, the usual like and subscribe, that type of thing. Pass the word on. And thank you for tuning in to the sky this month. Gives me great pleasure to introduce to you our guest speaker who is joining us from the University of Colorado. It's Dr. Fran Bagenal, and she is a research scientist at the Laboratory for Atmospheric and Space Physics at the University of Colorado. And she loves to study magnetic fields and particles that are trapped in those magnetic fields. And she's currently doing research with the information coming from the Juno mission. And you can see that behind me. That's a picture of the Juno satellite in orbit around Jupiter. And of course, it's an artist's depiction because we didn't have our camera crew there taking this photo and such. But Dr. Bagenal has been incredibly involved with space missions. She was involved with the Galileo mission, which was at Jupiter back in the 90s. She was involved with the Cassini mission at Saturn that met its demise just 7 years or so ago. She's been involved with the New Horizons missions, one of my favorite missions, to Pluto and Arrokoth. And she's been involved with Voyager 1 and Voyager 2, and currently with the Juno mission. And she has just a wealth of information about Jupiter and Io, she calls it. Most of us call it Io, but it's just a fascinating study that Juno is there and has gotten so close to Io. So, Dr. Bagnall, tell us a little bit about what are we looking at now from Io?
So what we're seeing here is Io's surface with a lot of volcanoes. The black bits are lava. That's like molten rock, very much like the Earth's molten rock, spewing out of these volcanoes. But also, these volcanoes spew out gases, SO2, frost, which is that white material that covers the surface, and actually evaporates to make an atmosphere. And then sulfur, which is the more orangey, reddy stuff, that also comes out of these volcanoes. So this big one on the left is about 300 kilometers across. So that's sort of usually the size of a typical American state. And you can see it's here, the lava here spewing out. Now, if we go to the next one, this is a zoom in, and you can see the heat flow coming out of this volcano, Amirani. And this is in the infrared. So we're seeing the glow of the hotspots along that volcano. And this is spewing out a lot of energy, the heat coming out and being visible in infrared light. Now, when we look at Amirani itself, it covers something like a few blocks of in a city block or two, several, say 3 or 4 city blocks per day. So that's a big volume coming out over the year. And then we look at the global resurfacing. It's about 100 times the lava flow on the Earth. Now it's a thin if it was spread out over the whole moon, but when it removes all the craters within a million years, so you don't see any craters on Io. They've all been covered up by lava, and it would turn over, the whole moon would turn over inside about 40 times over the age of the solar system. So it's very active volcanism. And then here are some pictures zooming in and seeing the lava flows as observed by Galileo. Here we see some active volcanism that's glowing, and also big mountains on the right, sticking up, height of Everest, more or less. And then we see changes from time to time. These are 2 different Galileo pictures showing how at different epochs, this was only a few months apart, between November of 1999 and February of 2000, you can see there's a change in the volcanic activity. And indeed, we see changes in the surface geology, changes in the activity in the infrared, as well as surface coverage. And then we have eruptive volcanism, where we have dust and lava coming out of the volcanoes that you can see. This is Tvashtar erupting near the poles, and then the gas comes out with this. So here, this gives you the numbers, about 100 erupting volcanoes over the whole moon, much more active than the Earth.
As we look at Io, what is it that makes Io so different from Ganymede, Callisto, and Europa?
Here, we have the 4 Galilean moons, and the big difference between these 4 Galilean moons is the degree of tidal forces. So this orbital resonance of Ganymede going around once to every twice that Europa goes around and 4 times that Io goes around Jupiter, this leads to tidal coupling between these moons, just as the Earth's moon produces tides on the Earth's ocean goes up and down. In the case of Io and Europa, they have their crust getting flexed and going up and down, similar to the Earth's ocean going up and down. And this leads to heating of the interior, removing of all of the water from Io and a lot of the water from Europa, and it drives this volcanic activity. And that causes the biggest difference between these 3 moons.
That helps explain the difference. Tidal forces are huge, and Io is obviously a very active place. Tell us more about how Io is changing.
When you look at, and you can see changes on the surface several months apart, things like that. Now, we look at the nighttime, you can see glowing from the heat. But also this particular picture that was taken by New Horizons on its way to Pluto, you can see this big plume of volcano sticking up, material sticking up 350 kilometers high. So that's half the way out to the space station, if you were to think of the Earth in terms of how much above the surface we're talking. It's a big, very large plume. And here you can see this movie of it erupting. This one called.
And that's actually, what actually is the substance that's coming out of that volcano?
What you're seeing is dust coming out and pieces of lava coming out. You don't, but there's also gases which you can't see, sulfur dioxide. And the picture on the bottom right is from an Earth telescope looking in the infrared, and you can see there's these dots all over the surface. When we went with Juno flying past, the infrared camera here, which is called GIRAM, it's made in Italy, has made these amazing pictures of the volcanoes on Io, and you can see, 100 active volcanoes. It's a lot of activity going on. Here's an example showing variations with time, and if you look carefully, you can see that some of these volcanoes are a bit different, and I'm trying to find, I can't find a specific case right now. Okay, but let's look at, here's one where you can maybe see that there are changes. So for example, this group here is the same as this group here, and they've got different eruptions, different kinds of, they look a bit different. Okay. So this is a very active moon with a lot going on, lots of hot spots, lots of mountains, a lot of volcanic activity. Now, there were some new ones that were detected by Juno up here. And there's some question, looking at the ground-based observations, whether or not there's these changes in volcanic activity as observed all the way back to 1990 are systematic in their behavior. And show you some Juno pictures that were taken on the 30th of December. So that's what, less than 2 weeks ago, the Juno mission flew by and Io and took these pictures. It flew about 1,500 kilometers above the surface. So that's about 80% of the radius. So it's about 1.8 Io radii above the center of Io. And there are, again, about 100 of these things erupting. Now, we haven't got seen the infrared pictures showing you the active volcanism, but look a bit more carefully at these 2 pictures. The one on the left is just a black and white, and on the right we've added the color. But what you can see, because we're looking sort of close to the limb here, the day-night side change, you can see these ones sticking up a long way. And in the black and white in particular, it really stands out, and you can see these big mountains. And these big volcanic mountains are, again, about as high as Everest. Now, remember, it's smaller than Earth, so the gravity's weaker. And so you can stick up these mountains a long way, but these are really big, dramatic mountains. And then the black bits are the lava. And we expect when we get the infrared data back from Juno, which I hope any day now we'll get to see, you will see the active hot lava in these regions. So this is a really beautiful data showing up close the volcanism on Io that Juno has been able to explore and see in detail.
So is it true that Juno got within 1,000 miles of Io on December 30th, 2023?
Yeah, that's about right. The distance from Io. And so that's why we were able to get good pictures. But we were a little nervous because also close to Io, there are electrical currents flowing between Io and Jupiter, producing aurora on the atmosphere of Jupiter. So these electrical currents, 1,000,000 amp currents flowing from the region around Io up to Jupiter. And we were a bit nervous flying through those regions, what it would do to the spacecraft. But we survived and everything's good so far. Fingers crossed.
You say Io. I have always said Io. I'm starting on this show to say it Io. But why the difference? Why do you call it Io?
Well, it doesn't matter. It's up to you. Io, Io, tomato, tomato, who cares? But it is really, the reason I say Io is because it's a Greek word. It was a Greek character. And and the Greeks would say Io.
That makes sense to me. Hey, does Io have an atmosphere of its own?
It does have an atmosphere. Its atmosphere is SO2, and it's much less dense than Earth's atmosphere, but it's more than Europa's or Ganymede's. But it's driven by sublimation, evaporation of SO2 from the surface. This frost you're seeing over here on the right, the white stuff, is SO2 frost.
Oh,
It evaporates.
and that's sulfur dioxide?
Sulfur dioxide, that's right. Sulfur and oxygen.
Who would have thought? Well, in terms of this Juno mission as it's orbiting Jupiter, and now it's getting really close to Io, closer than 1,000 miles, were there any surprises? Did we find out some things that we just weren't expecting?
Well, from what we've seen so far, I think the biggest surprise is the sharpness and height of these mountains. So if you look at this one down here, just sticking up like this, it's very sharp. And so then comes the question for the geologist, how can you make a mountain this shape sticking up, so sort of upright like that? And I don't think we know the answers, and look forward to hearing from the geologists what their theories are.
So if a volcano at Io is erupting, about how long does an eruption go on?
I think that varies a lot between different volcanoes and locations. And what we've been seeing is the volcanoes near the equator may be a bit different from the volcanoes near the poles. And this is something that we're interested in knowing. The tidal forcing tends to heat the equatorial regions. And so we have the strongest, hottest volcanoes near the equator. But at some point, the volcanoes get clogged up and then another one erupts nearby. So we have seen volcanoes that seem to have been erupting maybe even as long ago as Voyager, 1977, but they may have, it may have been episodic. We don't look at Io all the time continuously. And so it could be that they come and go every year or every few years.
Okay, so you've talked a bit about sulfur dioxide frost. Are there any other elements or compounds that are common or surprisingly there at Io?
The black stuff is lava. So much like the lava on Earth, this is silicates. So silica, silicon plus metals like iron and magnesium and calcium and so on, as well as some oxygen, magnesium, and so on, that make up rocks, similar to the rocks of Earth, we think.
Well, Dr. Bagnall, this has been such a fascinating discussion of these recent findings by the Juno mission at Io. Just amazing stuff, and thank you so much for sharing your wealth of information from the new data that has come down, and thank you for being part of our show on The Sky This Month.
It's a pleasure.
Well, I hope that you enjoyed that discussion with Dr. Bagnall. And one thing that she didn't mention in terms of my asking questions, but there could be 250 volcanoes on Io with 100 volcanoes erupting at any one time. Just a fascinating place. I hope that you enjoyed the show. Again, please tell your friends and family about The Sky This Month with your host, Dave McDonald. And we'll see you next month. We're getting closer and closer to the April 8th eclipse, which crosses America. And we're going to talk a little bit more about that in March, as well as some other things as well. So thank you so much for joining us. Remember to keep looking up. I'm Dave McDonald for The Sky This Month.